This is just a shortcut way to identify a prime number, that all prime number except 2 and 3 can be written in form of 6 and plus minus 1. And if you start putting the values of n 1, 2, 3 and up to so on, if this is 1, this will be 6 plus 1 7 and 6 minus 1 5. Both are prime number. If this is 2, this will become 13, 12 plus 1 and 12 minus 1 11. If this is 3, this will become 19 and this will become 17, right? But the only drawback is that this may include extra number as well.
Any number or any prime number compulsory in this formula?
No, you can use any number, 1, 2, 3, but only positive numbers, right? You're getting my point, what I'm saying?
Yes.
Please mute yourself.
There is something noise behind you.
Okay. So moving further, but the only thing is that there could be extra number as well. So this is not a hard and fast. So this is just a sort of shortcut way to identify a prime number. We will discuss this a bit further, a bit later. Okay. Can we know? Let's suppose we have a number. Let's suppose which is 120. Can we identify whether this is a prime number or not? One way which we discussed earlier. The other way is
not a prime number.
Yes, I know this is not a prime number. I'm just showing you the way how to do that. If you take the
Factorization, maybe.
If you take the square root of this is a bit greater than 10 and a bit less than 11. Let's suppose 10 point something, whatever the value is, right? So see the prime number less than that, whatever. We got 10 point something, right? So what are the prime number less than this? That is 2, 3, 5 and 7, right? Divide this 120 by these 4 number. If this is divisible by this number, this is not a prime number. And if it's not divisible by this is a prime number. Getting my point, or shall I repeat?
Sorry, can you repeat this? 2, 3, 5, 7.
I'm saying that let's first take any other value. If you take 100, just giving an example. If you take 100, the square root of this is 10, right? Just see what are the prime. There is a distraction. Just see what are the prime number less than this, which are 2, 3, 5 and 7. Now the prime number you got, just divide those 100 by those, and if 100 is divisible by those, that value is not a prime number. And if it not is divisible, then that is a prime number. The takeaway is just take the square root and see what are the prime number less than that, and see whether the actual number is divisible by that number, those prime numbers or not. If that is divisible by those prime number, the actual number is not a prime number. As in our case, this is 100 and 100 is divisible by 2. So this is not a prime number. If you take any prime number, let's suppose you take 29, and square root 29 is what? This is 5 point something, right? And the prime number less than 5 is 2, 5 point something is 2, 3 and 5. And 29 is neither divisible by 2, nor by 5, nor by 3. So 29 is a prime number, right? Shall I proceed further now? I'm just giving you the idea how to check the prime, whether it's a number is a prime number or not.
But in the case of 100, it is not divisible by 7, right?
Doesn't matter. If it's divisible by
so
any
is
single
it
value.
still a prime number?
The point is it should be divisible by any of the number. If divisible by 2, it is not a prime number. If by 3, not a prime number. Doesn't matter whether this is 1 or 2. It must be not be divisible by any of these values.
So if 100, that means 100 is divisible by 2, so it is not a prime number, like that?
Yes, exactly.
Okay.
I think in case of last digit is
even number, it's never be prime number.
Yes, sir. I know
Beside
that
two.
thing. Yes, you're exactly right. I'm just giving you idea. Doesn't matter. I just take 100 as example to give you an idea. You can take any value and check this and verify this. Now, before solving some questions for prime number, we'll first discuss about the even and odd numbers, because the questions of prime numbers and even and odd number are highly linked. That's why we'll first proceed with some example. We will discuss about the even and odd number, then we'll proceed for the problems. Right? We will discuss some problem later. So, starting with the even integer. What is an even integer? Even integer is a integer that is divided by 2. If we divide that by 2, the remainder is 0, right? Let's suppose that is 0, 2, 4, 6, and yeah, that's negative as well, -2, -4, up to so on. And we could write these in generic term in form of 2a, where a could be a positive integer, negative integer, or 0, right? If a is 1, this will become 2. If a is 2, this will become 4. If a is 0, 0 can be divided by 2. 0 is an even integer.
Alicia, can you mute yourself?
Okay. I will take question and then okay. So this is about just basic thing about even integer. Now, the other thing is odd integers. So odd integers are those integers which are not divisible by 2, and if we divide by 2, the remainder is 1. Like 1, 3, 5, 7, -1, -3. And if we try to form some generic pattern for this, that could be 2a plus 1, where a could be positive integer, negative integer, or 0, right? Now let's discuss some generic operations of the even and odd integers. First, let's discuss about the addition. If we add two even numbers, the result is always even. For example, if we have even number 2, if we add 2, the result is 4, right? Okay. If we have one odd and if we add another odd, the result is again even. So take example 1 plus 1, this is 2, right? Now, if we have one even and one odd, the result in that case is odd. If we 1 plus 2 is 3, or 2 plus 1 is 3, right? So takeaway is that we will get only even when we are adding the two same terms. By same terms, I mean, no, this can't be in fraction. This must be an integer. I mean, if both are even or both are odd, the result is even. So you can get only odd in one case, if one is odd and one is even, or if this is even or this is odd, right? Okay, so this is about addition. Same properties are hold for subtraction part. For subtraction, if we subtract two even numbers, the result is still even. 2 minus 2, this is 0. If we subtract two odd integers, the result is always even. Like 1 minus 1, this is 0. And if we subtract two different, one is even, one is odd, or one is odd, one is even, the result is odd, right? Take an example, 2 minus 1, this is 1. 1 minus 2, this is -1. Take any example. The takeaway is you can get only even when both are same, both are even odd, or both are even, either even. If both are different, you will get a different term. You will get an odd. So this is about addition and subtraction. Now, about multiplication. This is very simple. For multiplication, if one is even and one is odd, the result is even. If one is even and other one even as well, the result is even. If one is odd and other is odd, the result is odd. So the point is, you will get always even when there is at least one even in this. For getting odd, all of these must be odd. For example, 2 into 1, this is 2. 2 into 2, this is 4. So 1 into 1, this is 1, right? So this is very simple. For getting even, at least there should be one even, and getting odd, there must be, all of them must be odd. Now for division, things are a bit complicated. Now let's see each of the case separately. If we divide even by even, there could be multiple scenarios. The result could be even, the result could be odd, the result could be even non-integer value. For example, if we have 4 and we divide that by 2, both are even, the result is 2. If we have 6, we divide by 2, the result is 3. This is even, this is odd. And if we have 6, we divide by 4, this is 3 by 2, and this is non-integer, right? So we could get multiple answers based on this. Okay, this is first observation. Now the other observation is, if we divide even by odd, the result is either even or non-integer value. This can't be odd. For example, if this is odd, this is even, the result is 2, which is even integer. And if this is 4, we divide by 3, this is odd, this is even, the result is a non-integer value, right? So in this case, there are only two possible values. One is even and one is non-integer value. This is second case. Now moving to the third case. If both of these are odd, if you are dividing odd by odd, in this scenario, there could be either odd answer or there could be a non-integer value. Whatever I'm writing, just practice along. This will be helpful. Okay. So if this is 3, this is 1, the result is 3, which is odd. If this is 3, this is 5, the result is a non-integer, right? And the last thing is, when we are dividing odd by even, this will always result in a non-integer value. Like 3 divided by 2, this is a non-integer value. But I'm just taking the question for this. Afterward, we'll proceed further. Let's just ask if anyone is confused till now. No one? Okay. Now we'll discuss a bit about exponents involving even and odd. First, let's suppose if we consider odd basis. Let's suppose we have an odd number and its power is positive even integer. I mean greater than 0, right? The result is always odd. For example, if I take the square of 1, the result is 1, which is odd. This is first case. The second scenario is, if I was odd base and if I take the positive odd integer as power, again the result will be odd, right? Take an example, 3 or 1, the result is again odd, right? Now, if again I have an odd base and if I take the 0 as power, the result is again odd. And this is a very important property. Okay, so you take 0, the result is 1, which is odd. And the last thing is, The last part is if you have an odd base and you take the negative integer as power. In this case, there could be multiple scenarios. For example, if we have a take any value, we have 3 and we take -2. This will become 1/3 square. This will become 1/9, a non-integer value. And if we have -1, we take power -1, result is -1, which is integer value. I'm just showing you the scenarios. Yes, 0 is included in even integers. Okay, perfect. So this is just a bit about the when we have odd bases. Now, if we have an even basis, for example, if you have even base and if we take the power as positive even, the result is even. Take an example, 2 power 2, the result is 4, right? If we have an even base and if we take the positive odd as a power, so this is 2 power 3, this is 8, again even. Now, if we have an even base and if I take the 0 as power, result will become 1, which is odd. It is always odd, right? This is highly tested property in even and odd questions. I have a question we'll discuss further, but this is highly tested, so keep an eye on this. And the last one is if we have an even base and we have a negative power, negative integer power. So there are again multiple scenarios, just like if we have 4 and if we take the -2 power, this will become 1/16. If we have 0 and whatever I take the power, the result is 0. So this is even integer and this is not even an integer. This is not an integer, right? So this is just a bit idea about if we are considering the even and odds in power are in arithmetic operations, right? Any issues till now?
So this
Madam,
1/16, will it include under non-integers?
Not an integer.
Non-integer.
Yes, we discussed yesterday that integer is a further form of rational number in which 2 is equal to 1. But this is a fraction, this is not an integer. Right?
Yes, we can write it actually 1/4 square equal to 1/16. Then we'll understand it very easily.
Sorry, I'm not getting what you are saying.
I can actually, if I consider 1/4 square, since for inverse 2, so I can write it 1/4 square.
Yes. This is equal
Then
to 1/4 square, and this is 1/16.
Yes, yes.
There is no such term 1/0 in GRE. In actual math, this is infinity, but for GRE, we don't consider such terms. Okay.
Madam, can you please repeat the -1 to the power -1?
-1 to the power -1. Just
Yes.
remember one thing. Whenever you have a negative value and you take the odd power, the result is always odd. Sorry, odd, a negative value. Whenever you have a negative value and you take the odd power, the result is negative. Likewise, we have a -1. And if I take any other even power, so summary when odd is raised to,
We can
I have a confusion.
actually we can write it -1/1, 1/1. Then it
still
is
the answer is
usually
-1.
-1.
Yeah, I'm
Yes.
getting what you are saying. You are saying we will do this way, but still the answer is
Yes,
-1.
Yeah.
Right?
I have a confusion for even to the power non-negative number. Suppose 0 to the power -1. You have written 0 to the power -1.
Yes.
But as far I know, 0 to the power something means infinity. It can't be determined. 0 to the power something mean infinity. Am I right?
1 by
Yes, you
0.
are right.
Yes.
You are right. But for timing, I'm
So
saying that whatever you take the value of 0 in GRE, the result is 0. But
Yes.
Is it an assumption only?
the real thing that whatever you take the power of 0, result is 0.
Yes.
Yes.
Something
We can
power.
write it also 1
But
by
for a
0.
fraction, but for fraction, you cannot have a 0 in denominator.
Yes.
Now let's
Even 0 divided by 0 isn't possible.
no, still not possible in GRE. 1 over 0 and 0 over 0 is not any term in GRE. Right?
1 over 0 is infinity.
Yes, but we don't consider any such term in GRE. Okay, so let's back to the question. The first question is very simple question. Okay. The first question is very simple question. The question is that let's suppose x is an integer. The question is which of the following must be even? So you have 5 options. First one is x square minus x minus 1, x square minus 4x plus 6, x square minus 5x plus 5, x square plus 3x plus 8, and x square plus 2x plus 10, right? So the question is x is an integer, and the question is saying which of the following must be even. Just solve this question. Just take 2 minutes and try to solve this question. This question should not take more than 2 minutes. Yes?
D. Answer is
D.
D. D. Answer is D.
B, D, or E?
D.
Let's wait for 1 or 2 minutes. I'm more concerned with the way how you solve this.
Answer is D.
I think so. E.
Anyone else?
D. D.
Anyone still solving, or shall I solve this now?
I think answer is E.
D.
Answer is
D
E.
answer.
So
It
we
is
are having
D.
multiple answers. Anyone else?
I think it must be A, C, and D.
So can it have multiple answers or one answer?
Only one answer.
Only one
D.
answer.
Only one answer, then D. D.
Okay.
D.
Now just pay close.
That is D.
See closely the word must. If this is a good case, then there could be a multiple answer. But the question is saying must, so there must be at one answer. Unless the question state that indicate all possible answers, then in that case we could have multiple answers. Okay, so let's see each of these separately. The first one is x square minus x minus 1. One way to solve this is by assuming value, let's suppose for even 2 and for odd 1. In that case, you have to consider many values and solve. But I just told a bit earlier, I told you about arithmetic properties of even and odd. First, if we consider x as even, right? First case in which x is even. So this is even, and this is odd, right? The sum or subtraction of 2 even is even. And we are left with even minus odd, and even minus odd is always odd. Right? You can take any value and justify this. I'm just going through the generic terms of even odd which we discussed earlier. Now, if I take x as odd, so odd minus odd minus odd, I'm just translating this thing.
Even.
So odd minus odd is even, even minus odd, this is again odd.
Odd.
So this is not possible case, right? Now, if I move to the second option, and again, if I
Oh, this odd minus odd minus odd. How?
yes, I told you earlier that if we have two odds, subtract are added, the result is even. So even for this, and this is odd, even minus odd, this is odd, because we can get odd when we have one even and one odd, right?
But here odd, I mean, we are considering x as odd, right?
Yes, in this case, we are
So
considering
x
as odd.
square is the right x square. So it becomes, if we case 3 square, then again odd. Okay, okay.
That's why I just told you earlier about all of the scenarios of the power, of the fraction, of the division, multiplication, addition, and subtraction. Okay. Now, this is a very quick way. And to be honest, I will hardly take a minute to solve this question. If I've moved to this, and first is even minus even plus even, and this is even plus even is even. So first scenario is yes. If I take x as odd, right? So odd minus even plus even. This is even, odd minus even is odd. Again, not possible. So this is again not possible. Right? Everyone is with me?
No, sir.
Where is the confusion?
Please repeat.
I'm saying that I'm considering two cases because we are just given x as integer. So we should consider x as even as well and odd as well, right? Now,
Okay.
at first I consider x as even. So even square is even into even is even. This is even, this is even, and 6 is even, right? The addition or subtraction of 2 even is even, right? And even plus even is again even. So in first case, we get even answer, right?
Okay.
Now moving to the second case, odd square is odd into even is even. If we multiply any length, any number, and in that at least one is integer is even, the product is even, right? So that's why this is even. You can take some example and try to solve that way, right? This is even and 6 is even, right? So even plus even is even, and even minus odd is odd. So we are, for this scenario B, this is not possible because the question is saying must be true. So both of these should be even so that we can choose option B. But only one case is even, so we cannot choose that, right?
Odd minus even is
Yes, yes. Odd minus even is odd.
odd. Then okay, okay. Then odd plus e, right?
Please mute yourself. Okay. Now coming to the third part, part C. If I consider x as even, so this is even minus even plus odd. So these two result is even plus odd, and result is odd, right? So in one scenario, this is odd. And if I take x as odd, so this will be odd minus odd plus odd. So sum of two odd is always even, and odd minus even is odd. So this is again not possible. So C is again ruled out. If anyone is having confusion, please ask me. I'm just proceeding based on what I explained earlier.
Sir, I think it's wise to just input the lowest number, like I have done by inputting 1 or 2 in every cases. For 1, which will be the value, and for 2, which will be the value. Then I easily found out which will be even.
Yes, you can do that, but that will be a time-consuming approach. That's why I told you to try to solve these by generic terms. Otherwise, if you solve by taking values, you could have, you might have to take multiple values to prove that point. But in generic term, that will be a very quick way. Just after this session, try to use some values and try to memorize these operations. Then you will able to solve these type of question very quickly, because this is very simple question. The question which I have further to solve, those are very bit difficult question. And if you start putting values, I guarantee you won't able to solve such question in exam. Right? Okay.
Yeah.
Okay, the issue is I was using the trial version and this session is about to expire. And if anyone of you want to continue, just again join that link. Okay. Join the link again.